Next type of identities we're going to cover, and you can look on your identity sheet. It's over on the right. No, what's that? Right, second row, second and third columns. We're going to cover double and half angle identities. Here you see your list of double angle identities. Sine of 2x, there's only one. For sine of 2x is equal to 2 sine x cosine of x. You have three different double identities for cosine 2x and one for tangent of 2x. I'll show you how to use them. Find the sine of 120, cosine of 120, and tangent of 120 by using double angle identities. We already know the sine of 120. Everybody understand that? We already know the cosine of 120. That's one of your common angles. This is just getting extra practice using our double and half angle identities. Let's start out with this. My double angle identity for sine of 2x is sine of 2x equals 2 sine x cosine x. Now, think about it, how could I use this identity to find the sine of 120? And again, let me share with you, this is honestly not how you're going to be using these identities. This is just a problem that's going to give you extra practice with them. Okay, just so you're comfortable, you're familiar with them. If I want to find the sine of 120, question is, what could I put, and by the way, x could be alpha, beta, theta, some other variable. What could I put in for x to find the sine of 120? If we want the sine of 120, what's the value of x right here? 60. Because 2 times 60 is 120. So in order to find the sine of 120, that's the same thing as the sine of 2 times 60. So in the place of x, I'm putting 60 degrees. So in order to find the sine of 120, I'm going to do 2 times the sine of 60 times the cosine of 60. What is the sine of 60? What is the cosine of 60? And I know that 2 and 1/2 cancel each other out and gives me root 3 over 2. And like I said, that's one we already knew. The sine of 120, there's 90, 120 is going to be there. My reference angle is 60 degrees. Since I'm in the second quadrant, sine is positive, so sine is root 3 over 2. That was easy. Like I said, I already knew it, but just showing you how to use these identities using something we do already know. Cosine of 120. So we go cosine 120. We do know that that's equal to the cosine of 2 times 60, which fits perfectly into our double angle identity. The double angle identity actually states, and we can use several different ones here. Let's do the cosine of 2x equals, I don't know which one we want to do. We'll do cosine squared x minus sine squared x. So therefore, in the place of x, I've got 60, so that'd be cosine of 60 degrees squared minus the sine of 60 degrees squared. We'll actually work it a couple of different ways. We'll do this one first. What is cosine of 60? Half, right? Square that, you get a fourth. Minus, what is the sine of 60? And when you square that, when you square root, it simply takes away the square root. When you square 2, you get 4. So we got 1/4 minus 3/4, which is negative 2/4, or negative 1/2. And like I said, we already know cosine of 120. Cosine of 120 has a reference angle of 60 degrees. The cosine of 60 degrees is 1/2. Since we're in the second quadrant, it's going to be negative 1/2. Like I said, you can use any of those. You're going to come up with the same answer. Cosine of 2x. Let's do one of the other ones just to show you. Cosine of 2x is also equal to 1 minus 2 sine squared. Where in this case, again, our x is 60 degrees. You're probably going to like these better because you don't have to plug in 2 different places. So you have 1 minus 2 times sine squared of 60, the sine of 60 squared. So 1 minus 2 times the sine of 60 was root 3 over 2. When you square root 3 over 2, you get 3/4. So that'd be 1 minus 6/4, which would be 1 minus 1.5, which would be negative 1/2. Same answer. Any questions? Tangent 120. The tangent of 120 is the same thing as the tangent of 2 times 60. Just to fit into your formula. Your double angle identity for tangent looks like this. The tangent of 2x equals 2 tan x over 1 minus tan squared x. So everywhere you have an x, pretty much you're placing the 60 degrees to fit into this formula. X is 60. So therefore we have 2 times the tan of 60 over 1 minus tan squared 60. Anybody know what the tangent of 60 is? Good. So we have 2 times root 3, or just 2 root 3, over 1 minus, the tangent of 60 is root 3, but we got to square it, which would be just 3. You've got 2 root 3 over negative 2, right? 2's cancel and leaves you with negative root 3. Same thing. 120 is a second quadrant angle with a reference angle of 60 degrees. I know that the tangent of 60 degrees is root 3, but since you're in the second quadrant, it would be negative root 3, so it does check out. That brings us down to half angle identities, and again, if you just want to make note on here, we're not doing all of these identities, but your half angle identities right next to your double angle identities there. You got them all copied down. Says use the half angle identity to find the exact value of the sine of 75. Now here, this is what we don't know. But we did have another method of finding the sine of 75. Don't write this down, but just revisiting. We could have done the sine of 45 plus 30. Remember the other day we did that. That's another way you could actually use your sum identities, sum and difference identities to find sine of 75. Let's do it a new way. I know that the sine of 75 is equal to the sine of 75 is half of 150. So I could write that as 150 degrees divided by 2. You can write it in this half format, this something divided by 2, and you can actually use your half angle identity now. Let me scoot this out of the way. Your formula states this. I'll write it right above it. The sine of x over 2, or let's do theta. The sine of theta over 2 equals plus and minus square root of 1 minus the cosine of theta over 2. So pretty much all we're doing here, in the place of theta, I have 150. So everywhere I have a theta, I put a 150. Okay. So plus and minus. Now let's go ahead and take care of plus and minus. We're finding the sine of 75. Since you're in the first quadrant, sine is going to be positive or negative. Positive, so you can get rid of that. Instead of plus and minus, just the square root of 1 minus the cosine of 150 degrees over 2. Cosine 150. Let's see. All students take calculus. 150 is going to be reference angle of 30. Since you're in the second quadrant, cosine will be negative. Since you have a reference angle of 30 degrees, cosine will be good. So it'll be negative root 3 over 2. So that's 1 minus negative, which would be plus, root 3 over 2, over 2. Now let's review how to clean this up. This is just a little extra algebra practice here. Before you can add these two things together, you need common denominators. That'd be 2 over 2 plus root 3 over 2. So now you have the square root of 2 plus root 3 over 2 over 2. To divide two fractions, you flip and multiply. Come over here. That's going to be 2 plus root 3 over 4, square root of that. Which will actually be, you can split that into two different things. That's going to be the square root of 2 plus root 3 over the square root of 4, which is 2. That's not identical to how your answer would have looked the other way. We know that if we'd have done the sine of 45 plus 30, it wouldn't look like that, but either answer is right. They're both going to be exact. They're both going to come out to be the exact same thing. Next one says use a half angle identity to find the exact value of cosine of pi over 8. What would you do first? Definitely. I have no idea what pi over 8 is. Okay, so I would turn that into a degree. Pi divided by 8, 180 divided by 8 is 22 and a half. Yeah. 22 and a half degrees. If you double 22 and a half degrees, what do you get? I'm going to double that in your head. Yeah. So is everybody okay that what I'm looking for is the cosine of 22 and a half degrees, which is 45 degrees divided by 2. Write it in this format. Write your formula down, just so you got it there. The actual formula says the cosine of theta divided by 2 is equal to, and in the place of theta, we see what we got. The cosine of theta divided by 2 equals plus or minus the square root of 1 plus the cosine of theta over 2. Your sine and the cosines there is identical except for the difference, the plus and minus. So again, we come down here and just simply, everywhere we have a theta, we put a 45. So plus and minus, let's go ahead and take care of that, plus or minus. We're looking for the cosine of 22.5. That's our whole goal. Find the cosine of 22.5. That's in the first quadrant. Cosine will be positive. So we can drop the positive negative sign. 1 plus the cosine of 45 over 2. 1 plus, what is the cosine of 45? Canada? Here's all your angles. 0, 30, 45. There's one we're looking for, 60, 90. Make sure, guys, we know how to count with the, it's trig counting. 0, 1/2, root 2 over 2, root 3 over 2, 1. 0, 1/2, root 2 over 2, root 3 over 2, 1. If you're finding the sine of 0 is 0. It's 0. Sine of 30 is 1/2. Sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. Sine of 90 is 1. If you look for cosine, you do the exact same thing backwards. And we're doing the cosine of 45. And y'all start to notice 45 degrees will always be whether you find a sine or cosine. It's always root 2 over 2. So cosine of 45 is root 2 over 2. Common denominator on top, same as we did last time, is 2. So 2 over 2. We now have 2 plus root 2 over 2 over 2 and the second root. Lots of 2's. To divide two fractions, you flip and multiply, and the 2 goes away for just a second. 2 plus the square root of 2 over 4. But then when you take the square root of that, you have the square root of the top, which is 2 plus root 2, the square root of the bottom, which is 2. So the exact value of the cosine of 22.5 is the square root of 2 plus root 2 all over 2. Any questions? It says find the sine of alpha over 2. Find the sine of half an angle given the sine of alpha is 3/5. So let's go about it like we did the other day. Let me show you the long way about this. Let me show you what we're actually doing here. It's telling me that the sine of alpha is 3/5. If I move that over, I can actually find alpha. Second sine of 3/5. Alpha is about 36.8 degrees. Well, actually, the reference angle for alpha is about 36.8 degrees, because notice what it says over here. But alpha is between, what's pi over 2? 90 degrees and 180 degrees. So alpha is actually in the second quadrant, and I shouldn't even put that 36.8 degrees there, because alpha is not that. Alpha, I know that sine in the second quadrant is also positive, so That's actually just my reference angle. So alpha will actually be 180 minus that, which is 180 minus the answer, 143.1 degrees. Okay, there's alpha. But what we're actually asked to do in this question is find the sine of half of alpha. The sine of half of alpha is going to be about 71.5 degrees, 71.55, something like that. So that's what we're finding the sine of. So could we just type in the sine? Yeah, we could. Okay. Our answer is going to be, let's see, half of alpha divided by 2. The sine of the answer, sine of half of alpha is going to be about 0.49 or 0.94868. But what we're actually going to do with this problem, we're going to find the sine of half of alpha without going through all the steps. Okay. Plus, notice something else about that. That was a rounded answer. We're going to find the exact value for the sine of half of alpha. We start with our formula. These are pretty easy. The sine of half of alpha, find it. The sine of alpha over 2 is equal to, plus and minus, the square root of 1 minus the cosine of alpha over 2. That's the formula. Let's start out with the whole plus minus thing. We're given that alpha is 3/5. We're looking for the sine of half of that. We're also given that alpha is in the second quadrant. Right? Alpha is somewhere between, actually we can use open. Alpha is somewhere between 90 and 180 degrees. Here's the first thing I want you to notice. Take those angles that are between 90 and 180. Half all of them. Those angles are in the second quadrant. Take 90 degrees, 91 degrees, 92 degrees, 95 degrees, 120, 140, 160, 180. Take them all and half them. These are in the second quadrant. Where's your half angles at? First, every one of them. If you're between 90 and 180 degrees, if you half all those angles, you are now between 45 and 90 degrees. Does everybody understand that? And that's what we're actually looking for. We're not looking for alpha. We're not looking for the sine of alpha. We're given that. We're looking for the sine of half of alpha. So that's what we need to know is what quadrant we're in there so that we'll know whether our sine of alpha over 2 will be positive or negative. So again, if alpha is in the second quadrant, if you half alpha, which is what we're looking for, you're going to be in the first quadrant. So your answer is going to be positive. You can deduct that negative. Sine, if you're in the first quadrant, the sine's going to be positive. So now to find the sine of alpha over 2, we simply plug in. Well, we got a problem. We don't know what the cosine of alpha is. We know what the sine of alpha is. I told you the easiest way. I always do this. Here's alpha. Sine is opposite over hypotenuse. What's that third side? That's a 3, 4, 5 right triangle. So what's the cosine of alpha? 4/5. Good. We're close. Cosine of alpha is not 4/5, but it is. Careful. Negative 4/5. Alpha is in the second quadrant. So when we're doing that, we're dealing with alpha. Right here, this is not alpha over 2. We're dealing with alpha. Alpha is in the second quadrant, so your cosine will be negative. So now let's plug everything in. So sine of alpha over 2 is equal to the square root, it's positive, of 1 minus negative 4/5 over 2. We clean it up for that. 5/5 plus 4/5 is 9/5 over 2. Take the square root of it. To flip and multiply, that would be the square root of 9/10. Everybody understand? That'll be, we can rationalize that, clean that up a little bit. That's the square root of 9 over the square root of 10. Multiply top and bottom by root 10. That'll be 3 root 10 over 10. That's the exact value of the sine of half of alpha. If the sine of alpha is 3/5, the sine of half of alpha will be 3 root 10 over 10. Let's do one more of these. Find the exact value of cosine of alpha over 2. The cosine of alpha over 2 is equal to this. Cosine alpha divided by 2 equals plus and minus the square root of 1 plus the cosine of alpha over 2. Plug in what we know. Well, first off, let's determine if cosine of alpha over 2 is going to be positive or negative. I wish I'd give you a different quadrant here. Alpha is in the second quadrant. It's between 90 and 180, so half of alpha, which is what we're looking for. Half of alpha will be in the first quadrant, so it will be positive. So we can do away with the negative there. Next up, we're given that the sine of alpha is 1/3. Now we're talking about alpha, not alpha over 2. The sine of alpha is 1/3, which, by the way, you can use Pythagorean identity here. Sine squared plus cosine squared equals 1. You can solve that equation and find cosine as well. Or I can use Pythagorean theorem. A squared plus b squared equals c squared. B will be the square root of 8, which is 2 root 2. And again, keep in mind we're in the second quadrant, where sine is positive, obviously, but cosine will be negative. Adjacent over hypotenuse, 2 root 2 over 3. So now we plug in, we're done. So therefore, the cosine of alpha over 2 will equal to the positive square root of 1 plus this. So it'll be a negative 2 root 2 over 3 over 2. You're going to get a lot of algebra practice today. Common denominator is 3, so this will be 3 over 3 minus that stuff. You've got 3 minus 2 root 2 over 3 over 2. And you can combine, if you get comfortable with that, you can combine these two steps here. That'll be the square root of 3 minus 2 root 2 over 6. Let's see if we can clean that up any. Let's actually clean it up here. Okay. I don't care if you leave it as, let's talk about the different ways we could leave it. We can do 3 over 6, which is a half, minus root 2 over 3. I'd be okay with that. If you want to, you can split it and rationalize it. That's the square root of 3 minus 2 root 2 over the square root of 6. Rationalize that by multiplying top and bottom by root 6. So that would be the square root of 18 minus 12 root 2 over 6. Which possibly could be cleaned up there. Let's see, you could pull out, no, you can't pull a perfect root out of both of them, can you? Pull 6 out. I like this one better. This looks much better. And again, that's the theory. You know, try both. Try to clean it up 2 or 3 different ways, and whatever way looks best, leave it like that. Or whatever way, if you're dealing with your ACT, whatever way it looks like the answer on the ACT, obviously, that's the answer that you want to give. First identity. And what we're doing, we're using our double and half angle identities here. And I believe our sum and difference, possibly. It says try to make the sine of 3x look like that stuff over there. The thing is, the stuff on the right side really, well, this kind of looks like, let's say, cosine squared minus sine squared. That looks kind of familiar. I look in here, cosine squared minus sine squared is the cosine of 2 theta, but we got a problem. We got 3 stuck on. If 3 was being multiplied by both of them, no problem, factor it out, and you could change it, but that doesn't help any. I'm going to do something unorthodox on this one. I'm actually going to start with the left side. And you might be saying, well, what in the world can you do with the left side? Now that we have more identities, we can do a good deal with it. But we're going to try to make this somehow look like this. And before it's over, I might end up working with both sides. I'm going to first take the sine of 3x, and I'm going to write it as the sine of 2x and x. And I know from my sum and difference identities, if you're going to look down there with me, now when you've got the sign of two things being added, I'll come over here and write the formula. The sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Move it down here so I have more room. And I could fit this to where here's my alpha, here's my beta. So let's rewrite it. I now have the sine of 2x cosine x plus cosine 2x sine x. We good so far? I split it. Now why? I don't know. I didn't know what else to do. I split it, wrote it using sine of alpha plus beta, using that sum identity there. Now I have sine 2x cosine x. Something else I notice now. I've got some double angles. Anytime you have sine of 2x or cosine 2x, I know I can rewrite those using my double angle identity. So let's just go that route and try. If it doesn't work, what do? Start over. I mean, that's when you're dealing with proofs. That's your road. A proof is a trial and error thing. You try something. If it doesn't work, try something different. If that doesn't work, try something else. Sine of 2x. Here we go. I know that the sine of 2x, if you look at your double angle identities, I know that the sine of 2x is equal to 2 times the sine of x times the cosine of x times, I've got a cosine of x stuck there, so let's go ahead and write that as cosine squared x plus the cosine of 2x. Now let's see, are we looking at anything like what we've got up there? Not really. Okay, but we're trying. I know that the cosine of 2x, let's try, you've got 3 different things. That's the only negative about your cosine of 2 thetas. You've got 3 different identities you can plug in there. I'm going to try cosine squared minus sine squared. I'm going to take out the cosine of 2x and put the cosine squared x minus sine squared x times sine x. Now let's do some algebra and clean it up some. I've got 2 sine x, and I'm going to take off the x's now, just to make it look a little bit better. Distribute sine x, we got sine x times cosine squared x. So sine times cosine squared minus sine to the third. Anybody notice anything we can do now? I'll sit here for a second, let you think. So here you go. So next step. Since both of these are sine cosine squares, there's one of them here, 2 of them here. Combine those together, that gives me 3 sine cosine squared minus sine to the third. Now look what our goal is. Look where we're at. Look what our goal is. It looks pretty close now. The only thing I noticed that in my answer, which is really what this is, I'm trying to make it look like this. This is my answer. In my answer, sine is factored out. So take this, factor sine out, and look what you've got. I'm going to put the x back in. Factor out sine of x, you're left with 3 cosine squared x minus sine squared x, which is identical to what you was trying to prove. So is the sine of 3x equal to 3x, or excuse me, sine x, 3 cosine squared x minus sine x? Yeah, sine squared x. Yes, it is. Okay, again, like I said, same strategy to begin with. We'll take cosine of 3x, split it into cosine of x plus 2x. Use our identity here for the sum of cosines. Cosine of alpha plus beta. Somebody will fill it in for me. That'd be the cosine of cosine, good, and then plus or minus, good, sine x, sine 2x. Everybody good with that? From there, your cosine 2x and your sine 2x. And hopefully you see when I'm dealing with these problems why I don't just take the x's out now. Well, there's two different x's. You got the cosine of a regular x and the cosine of a 2x. So I can't just take out all my arguments yet. But after this next step, I will. Cosine 2x, which one did y'all try? Which double angle did y'all plug in? Cosine squared minus sine squared. The only thing, and it'll probably work out. It'll probably work out. But the only thing I noticed is well, yeah, never mind. I was thinking that we were all cosine stuff. Here's a word of advice. When you're taking out cosine of 2x and you notice that up here in the problem that everything's cosine, but now here I've got some sine stuff. But what if it was all cosine stuff? I would probably use 2 cosine squared minus 1 when I plug it back in. Okay, just to get rid of all my sine stuff. But we do have a sine mixed in, so let's take out cosine 2x and plug in cosine squared minus sine squared. Minus sine x. The sine of 2x, we don't have much of an option. We're going to plug in 2 sine x cosine x. We clean it up. Josh, help me clean it up. Cosine times cosine squared is cosine to the third. Good. So we have cosine to the third x, and I'm going to leave the x off now. Cosine times sine squared, that's simply, you know what I'm going to do though? I'm going to put sine, yeah, I'll put cosine first, that's right. Cosine sine squared. Minus, Josh, clean up the second part for me. Sine times 2, I'm going to put the 2 first. So sine times cosine will be sine squared. Good. So there's what we've got now. And I did what I said I wasn't going to do. That'll be cosine sine squared. Doesn't matter which way you put it, just let's keep it uniform. Since I put cosine first here, put cosine first here. That way it's easier to recognize your like terms. And your like terms are here and here. So I got cosine to the third x minus 3 of those now, right? 3 cosine sine squared, which is actually what we're trying to prove. Worked out. So we have proven it is an identity. Before we start this one, I want you to add, I forgot about these two. I want you to add 2 more identities to your sheet. Probably won't use these near as much, but tangent of x over 2, or if you want to put theta over 2, that's fine, is also equal to, notice there's no plus minus sign here. Sine x over 1 plus cosine x. There's another half angle identity, or you could have 1 minus cosine x over sine x. On this proof, had you not used one of these, like I said a while ago, you're going to run into the dilemma of there was a plus minus sign in front of that other. And to replace tangent of x over 2 with a plus minus something, you've got 2 different scenarios there. And you'd have to try to prove both those scenarios. So we're actually going to use those when we're solving these. We'll keep it down here at the bottom. So here we go. I know one thing. We're not going to be working with the right side. 2 cosecant. There's not much there anyway. So I'm going to try to do something with tangent of x over 2 and cotangent of x over 2. Well, first off, I noticed that there's no cotangent of x over 2 on our identity sheet. Everything's tangent. But I do know that the cotangent is simply the reciprocal of tangent. So what you can do first, we got tan of x over 2 plus 1 over the tan of x over 2. Just write it using reciprocal identities. Next step, I'm going to take out my tan of x over 2's and put in this. So now I have the sine, and I can take my x's away because I just have plain x's now. Plus 1 over the sine times 1 plus cosine? Everybody good with that? Now this is going to be a pretty easy identity. 1 divided by something, flip and multiply, so now I have the sine over 1 plus cosine plus 1 plus cosine over sine. Watch how I get common denominators here. This will be pretty good. First off, I'm going to take over here and I'm going to multiply this by the conjugate. And try to think ahead as to what that's going to do. 1 plus cosine times 1 minus cosine will give me 1 minus cosine squared, correct? What is 1 minus cosine squared? Sine squared. If you take your Pythagorean identity, sine squared plus cosine squared is equal to 1. 1 plus cosine, 1 minus cosine, again, multiply to give you 1 minus cosine squared. When you move over cosine squared, 1 minus cosine squared is sine squared. Could I turn this into a sine squared? Sure, multiply top and bottom by sine. So now I have sine times 1 minus cosine. On bottom again I'm going to skip a step. I have 1 minus cosine squared, which is sine squared. And I think that's supposed to be a plus. Oh, there it is. That's plus. I'm going to multiply top and bottom by sine. So I've got plus sine times 1 plus cosine over sine squared. I can combine like terms, or I can, well, let's do this. Let's distribute on top. Sine minus sine cosine plus sine plus sine cosine all over sine squared. Minus sine cosine and plus sine cosine cancel out. Gives me 2 sines on top. Gives me sine squared on bottom. That's much cleaner. The sine that I have on top cancels with one of them on bottom, which leaves me with 2 over sine. How do I bring sine from the bottom to the top? Turn it into cosecant. Go back up, try to see what you're trying to prove. We're trying to make it equal to 2 cosecant x. So there you go.